Okay, so while we're waiting, I will introduce myself. I'm Yonatan. I will be the host of today's session. I am with the Axon team here at Hunters. And while we're waiting, I will make a few really quick notes that everyone always asks. So first of all, the session will be recorded, so you will be able to find this session after the talk in Hunters YouTube channel, and also the slides, which will be attached to the YouTube video as well. So don't worry, everything will be available after the talk. And yeah, the last one, feel free to ask questions here in the chat. I will try to take some of them during the webinar, and also Shelly will take the most important, interesting questions at the end of the webinar. So feel free to ask questions. And yeah, I think we can get started. I will hand over the mic to Shelly, which will introduce herself as well. Yeah, let's go.
Thanks, Yonatan. Hi, everyone. Good evening or morning, wherever you are. And thank you so much for joining. Our topic today is the rising threat of S3 ransomware attacks, how to detect and investigate them. It's a really interesting topic that I've been researching for quite some time now, and I'm really excited to share it with you finally. I personally think that detection in the cloud is not talked about enough, and I hope you gain some helpful takeaways from this talk. My name is Shelly Raban. I'm a proud cat mom to Nuni and Kimi, and I've been in the cybersecurity field in the past 6 years. In the first 4 years, I served in the Israeli Navy, and in the past 2 years, I've been with Hunters, where I'm a part of Team Axon. We're a part of Passionate Threat Hunters, and we provide threat hunting and incident investigation services on top of the Hunters SOC platform. The agenda for today, we're going to talk about the cloud ransomware landscape, what S3 has to do with ransomware. We'll break down some S3 attack scenarios, we'll see how they're carried out, and then we'll follow up with detection techniques and some visibility recommendations. And finally, we'll learn how to protect against these types of attacks. So let's start by speaking about the trend of ransomware shifting to the cloud. So I want to first emphasize how dominant S3 is for most large companies today, which is also why securing it is so crucial. As data keeps growing, businesses require scalable solutions. A noticeable trend is the increasing adoption of cloud-native storage. Roughly 50% today of the corporate data lives in the cloud, and Amazon S3 is a global data storage leader, serving millions of customers across various industries. It's also highly integrated into AWS services, and every organization that uses AWS also uses S3 heavily. It often contains intellectual property, financial data, customer data, and all kinds of sensitive data. So protecting it should be a concern to all its customers. So ransomware in S3 is rising, and let's talk about this trend for a little bit. So ransomware is a major threat, and it's continuously evolving. Cyber criminals continuously adapt, updating their playbooks, and their main goal is to maximize their profits. And we all know that data is shifting to the cloud and what opportunities it brings, but it also introduces risks, and threat actors pivot their focus accordingly. This makes S3 an attractive target. It is considered a very secure service of a very strong provider, but it is still exposed to the risk of ransomware. In the past, as some of you may remember, S3 buckets were used to be public by default, and this resulted in major data leaks. But AWS has mitigated this issue, resulting in more complex attacks by cloud-conscious threat actors. So you might be wondering what kinds of attacks I should focus on. Security practitioners are a limited resource. We don't have unlimited time. And a key strategy that our team uses is prioritizing TTPs that are actually leveraged by threat actors in the wild. One valuable resource to do exactly that and stay on top of the threats in the AWS landscape is the AWS Customer Security Incidents GitHub repo. It's a really cool resource, and even though most attacks in AWS are not publicly disclosed, it still brings a picture of AWS attacks in the wild, and it helps us prioritize our efforts accordingly. So, as we already mentioned, these attacks in AWS and specifically in S3 are rising. This trend was initially reported in the AWS Reinforced 2022 conference, and also AWS published a recent blog post about this attack. And some useful resources I wanted to mention is the S3 response playbooks that was published by the AWS CERT. To those of you who don't know, AWS CERT is the AWS IR team, and the ransom playbook for S3 really guides you through what events you should look for, what visibility you need, and what mitigations you can apply. Also, earlier this year, they released 5 hands-on IR workshops, and one of them was dedicated to S3 ransomware. So it's also a really cool hands-on experience with this attack. And an example for a real-world incident is from the Invictus IR team blog. They discussed an incident that happened in their customer environment where S3 buckets were exfiltrated and finally deleted. So this is also really interesting to read. Now that we understand the trend of ransomware shifting to the cloud, let's move on and talk about the attack itself. As we all know, the base for any detection is proper visibility. To be able to detect suspicious activity, we first need to have some kind of visibility into the activity. And when I shifted from working on endpoint detection to detections in AWS, I was really surprised to realize that almost each action in AWS is an API call, and almost each API call is both audited in CloudTrail and documented in the AWS documentation. This makes the life of a researcher a lot easier. And even without analyzing an actual attack, you can anticipate the behavior of relevant APIs by simply sifting through the logs and the documentation. So let's look at the 2 main options we have for logging activity in S3 buckets: CloudTrail data events and server access logs. So there are some pros and cons for each option. CloudTrail data events, first, they are not available by default. They are only enabled if you specifically enable them. And they provide real-time logging at a minimal delay. They cover all object-level operations, but their cost can be high due to the high volume of API calls. Imagine you have a bucket that is frequently accessed, maybe it's even public, and each object access is audited. Server access logging is free. You only pay for storing the logs, and it also provides visibility to object access. However, it may have a several-hour delay, and the completeness of the logs is not guaranteed. We also had a customer incident that we've investigated in our team, and I wanted to mention that because server access logs were really beneficial, and I can't emphasize enough how crucial it is to have this kind of visibility to object access when you suffer from an incident. It really provided valuable investigation insights. So I would recommend to enable them for any bucket since they are free apart from their storage, and they provide really crucial insights. And CloudTrail data events are a must for your sensitive buckets along with server access logs. They provide real-time detection opportunities, as we already mentioned, and logs integrity, but please do note that they may get costly.
Shelly, I have to ask, this table is pretty complicated. So the main takeaway that I understand from this table is that AWS CloudTrail data events are really critical for detection engineering and for visibility. From your experience, what is the popularity that organizations actually enable this data source? It's popular?
Yeah, so good question. Actually, data events are not so common among our customers, but I personally think like you monitor your crown jewels closely, you also want to monitor your critical buckets closely. So really, you don't want to find yourself investigating a data breach without having this kind of visibility. And I would really recommend enabling it, especially if you have sensitive data critical data for your business operations, this is really, really crucial. So no, it's not common enough. But yeah, the costs are a caveat, but you can also always enable the server access logging, which is completely free. So now that we've set up the proper visibility, we can dive into the attack flow. So we will discuss three main scenarios: object encryption, object deletion using straightforward delete operations, and object deletion using bucket lifecycle policies. We'll also see the permissions that are needed to execute each, the pros and cons from the attacker's perspective, and how to detect each of them. The final impact of all of them is that the organization's data is inaccessible and potentially leaked. The attacker may leak the files before deleting them or encrypting them and demand ransom for getting them back or not making them public. Also, it's important to keep in mind that the main initial access vector, as mentioned by the AWS cert, is the unintended disclosure of IAM access keys. So if you do cloud security, you probably know this attack vector, and it's really, really common. And in all these scenarios, we'll assume the attacker obtains such valid credentials in order to perform the following activities. And the compromised user may have the needed permissions to perform this attack, or the attacker may escalate his privileges in order to gain the required access. Also, like any other attack in AWS or in any platform, I would expect some discovery commands that the attacker would use to discover which kind of resources are accessible, and according to that, he can decide what attack to perform and on which resources. So let's dive into our first scenario, which involves object encryption. As we all know, ransomware commonly involves file encryption to deny an organization access to their files, and it really harms business operations, and the attacker can demand ransom for getting the files back. We will focus on server-side encryption, which is applied to data once it's written to the AWS data centers. And there are different types of server-side encryption. We won't dive into all of them in this talk. I will mention that the default one is the SSE S3, which is applied to all new buckets since the beginning of this year. And it does not prevent you to see the actual object contents. So if this is applied and you have access to objects, you can see their unencrypted contents. Our focus for today will be KMS. The KMS service is the key management service, and it lets you create and manage cryptographic keys across your applications and AWS services. And it has two main key types. One is AWS managed keys, and the other is customer managed keys. AWS managed keys are created and managed by AWS services, as their name suggests. And you cannot change any of their properties. You can't audit their usage, change the key policy, schedule them for deletion, or any of these operations. While customer managed keys allow you to do all of these actions. And our main focus and what's interesting for our attack scenario is that customer managed keys also allow a very granular key policy control that includes the option to separate and define who can use the key for encryption and who can use it for decryption. So when objects are KMS encrypted, only identities that have permission to decrypt object using the KMS key can decrypt the objects and see their contents. If you don't have this permission, even if you have access to the bucket, you can see the contents of the objects. So this is a really attractive approach for an attacker. Imagine that you have a native tool that allows you to deny the bucket owner access to his own object. You can do this exact thing by leveraging the KMS key policy. So now that we've set the stage and established a basic understanding of bucket encryption and KMS, let's dive into the first attack scenario. In our first scenario, S3 bucket objects are encrypted with a KMS key not owned by the organization. There are two accounts in this scenario, account A, which is the attacker control account, or another, it may be his personal account or another account that he's compromised. And attack B is our victim account. So first, the attacker creates a customer managed KMS key, as we discussed, in his own controlled account, and provides everyone access to use the KMS key for encryption. So you can see the policy, which we will soon dive into. And the attacker may schedule the deletion of the key, meaning once the key is deleted, the objects are inaccessible forever. And AWS allows scheduling anytime between 7 and 30 days for the key to be deleted. So the attacker may schedule it for deletion after 7 days, and then the files are lost forever. The second step is that the attacker gains access to a certain bucket, a write level access. And as we already mentioned, we assume he has some valid credentials of an IAM user, and he uses this IAM user to perform the next objectives. The IAM user credentials may be obtained through their leakage to a public repo or from a developer's machine or by any other means. And we will assume this already happened for our scenario. In the third stage, the attacker uses the AWS API to replace each bucket object with its encrypted form using the external KMS key that's controlled by the attacker. So now the victim, which is the bucket owner, tries to access his own objects, but he receives an access denied error because he doesn't have the KMS decrypt on the objects using the KMS key. And optionally, the attacker may also upload a final file such as ransomnote.txt without encryption, which instructs the target on how to get the files back and how to pay the ransom. One important thing to note is that cross-account usage of a KMS key for encryption is only allowed if both the external KMS key policy and the internal IAM user policy allow it, meaning the IAM user policy need to delegate the key, the option for the user to use an external key. This is a caveat for the attacker, and we will soon see that many policies that organizations configure still allow these activities. So it is probable that it will happen, but it's a small limitation. So what do we need in order to set up and simulate this attack ourselves? We need to have the AWS CLI installed or the Boto3 Python module. And for example, there's a really cool POC script by Rhino Labs to achieve exactly this scenario. We can also use the SDK, but it's just more complex, so I didn't include it here. And we need to set up our resources and policies. So we need to have our target bucket, the compromised IAM user, a customer managed KMS key from an external account, and the policies of the IAM and the resources. We need to set up our KMS key policy in the attacker control account, and we'll set it up with the KMS generate data key permission to the star principal, which is for everyone. And I saw some reports that mentioned the KMS encrypt permission is needed, but according to my tests, it's not required here, and you can achieve this using the KMS generate data key. In the victim account, account B, we need to allow the IAM user the same permission, the KMS generate data key, on the star resource. And this is the only permission you need in order to use the KMS key cross-account. So I inserted only the minimal permissions required for this to work, but realistically, the user might have the KMS star permission for all KMS operations. And I've also seen many cases where administrator access AWS managed policy is used, which allows practically any operation on any service or resource. So you really, really don't want to grant any of your IAM user this kind of permission. In the victim account, we'll also set up the bucket policy to allow our compromised user access to bucket objects. We need to have the get object, put object, and list bucket permissions. So let's dive in the simulation. In the first option, we use the copy object operation to recursively copy all the bucket objects within the bucket, meaning we overwrite the objects with their KMS encrypted version, with the KMS that's controlled by the attacker. So it's done within the bucket. No files are downloaded locally in the process. So this is a very convenient way to achieve this. And another way I found really cool to do this exactly and perform this scenario is to encrypt objects one by one by first getting them into our local machine and then putting them back to the exact location they were before, this time encrypted with the external KMS key. So the plus for this option is that the files are first downloaded to our machines, meaning we can leak them. We have access to the object contents, maybe it's sensitive data. And this is a really powerful thing to use to demand ransom, for example. So the before scenario of the bucket, we see here one of the objects. And when we access it as the bucket owner using a pre-signed URL, we can see the default encryption that we mentioned before, the SSES3 is applied to the object. And when we access it, we can just see the plaintext contents. And the after scenario, we can see the KMS key of the attacker was used in order to encrypt the file. So we suddenly see a KMS key that we're not familiar with, of an AWS account that we're not familiar with, which exists inside the ARN. And when we try to use the pre-signed URL, we get an access denied, even though we are the bucket owner. This is because we don't have the KMS decrypt permission on this resource. So I know this might be a lot to ingest, so let's do a quick recap. We set up the external KMS key. We only let other principals, or everyone actually, to use the key for encryption, but not decryption. We had the compromised IAM user that we obtained its access key from maybe a public repo or maybe from the developer machine. Then we used the permissions of the IAM user, or we escalated our privileges somehow to make all bucket objects inaccessible through encrypting them with the KMS key. This has a major impact that we really need to know how to detect from and protect from. So let's dive into the CloudTrail logs and see what is audited around the activity. So we can see sequential copy object operations or put object operations on an organization's S3 bucket. So in my research, I worked closely with the AWS documentation, and I really tried to find all the possible ways to achieve this goal. In this case, this was the object encryption. So I wanted to mention it's also possible to use the create multi-part upload API, which allows you to upload objects in multiple parts, but it's less likely because it requires a lot more operations. And in my experience, it also demanded the KMS decrypt permission, which is not likely that our IAM user has in this scenario. We can also expect an unusual user agent and source IP address because the attacker is operating from his own machine using our IAM user. So the IAM user suddenly starts to show up in the logs from a suspicious source. We can see a single ARN is used for all the copy object operations. In this case, it is our Axon user. And this is really the core of the attack and the main thing you want to focus your detection around. We see a KMS key in the request parameters from an unfamiliar AWS account. So this account is not owned by us, and this is a really suspicious thing if we don't recognize what this KMS key is or what the AWS account is. We can filter out AWS managed keys. As we already mentioned, they are not relevant for this thesis. So when we see AWS/service name as the prefix for the KMS key, we can just filter this out to avoid unnecessary noise. And one quick tip, if we want to filter out the the account that holds the bucket, meaning if the KMS key is from the same account, which is something that's not interesting for our scenario, we can just see if it's equal to the recipient account ID in CloudTrail. And this is really a quick win to filter out noise, since you don't have to join with any other table and you just have this data inside the event. So
Shelly,
this is
I have to jump in again, but this one is really interesting. But what about, I'm assuming that big organizations maintain a lot of different AWS accounts. So what about those organizations, like how they can improve the logic in case that they're maintaining a lot of different AWS accounts?
Yeah, so this is a really good question. And actually, most big corporates now do have multiple AWS accounts. And in Hunters, we maintain an automatically updated list of all the AWS accounts that each organization owns and filter all of them out in our logic, not only the recipient account ID. So this list can be gathered from the various AWS logs, for example, AWS config, VPC flow logs, CloudTrail, GuardDuty, any logs that you have available. And this can also be fetched from the AWS console. If you get into your management account, you can get all your accounts as well. So yeah, this is a really advanced way to fine-tune this query. Let's differentiate between successful and failed attempts. So in successful attempts, I found that the KMS key also appears in the response parameters. So this assures that the KMS key actually succeeded encrypting your object. The SSE applied, the server-side encryption, is SSE KMS, and no error code is found in the event. In comparison, in failed attempts, where, for example, I get an access denied because I don't have the necessary permission to do this operation, I don't have the KMS key in the response elements. I also don't have any SSE applied, and I have an error code of access denied. So now that we have our queue of alerts that our analysts need to triage and maybe escalate to a deeper investigation if needed, so how can we tune and prioritize alerts so that we focus only on the actually suspicious ones? One big challenge in this thesis is the copy object and put object operations are legitimate most times and are very high volume events. So setting up an alert for them without proper fine-tuning will generate a lot of noise. So how can we overcome this? We may filter out the cases where the initiating ARN account equals the KMS key account. So if an identity from an external account uses a KMS key from the same external account, it's likely an authorized third-party integration. It's a lot more suspicious if one of your IAM users suddenly starts using a KMS key from an external account that you're not familiar with. It does narrows down the scope to cases where identities from our account are being abused and not an integration role takeover, for example. So do note that. But if you experience noise from this query, this may be a very effective approach. Also, we should filter out activity initiated by AWS service. This is actually a quick tip for any AWS detection. You should really filter out such cases. And in this example, the S3 service is uploading server access logs to a bucket, and this is really something we don't want to alert on. Also, we really need to tune the alerts according to our environment. So, for example, you want to filter out a known integration role that is consistently used. Maybe it always uses the same KMS keys. Maybe all the KMS keys are owned by the same AWS accounts, and the activity is originating from a trusted IP range, and maybe it uses a consistent user agent, for example, the AWS SDK. And you really want to also prioritize less voluminous operations. So copy objects, in my experience, are a lot less common than put object. And if you really need to decrease the number of alerts you triage, I'd recommend prioritizing alerts of repetitive copy object first. Also, you want to prioritize cases of object overwrite where the source and destination bucket and the object name is the same. This would raise a suspicion. And as already mentioned, IAM users with long-term credentials are the most common initial access vector. So it would be a good idea to prioritize alerts that involve such users over alerts of roles with temporary credentials. Also, you always want to look for unusual source IPs or user agents in your logs. For example, if AWS CLI is used for the first time in a bucket, it should raise your suspicion. And if you have a mechanism to perform a learning period and baseline your user agents and IPs, it would be ideal. So we can now finalize our first scenario. This is our detection query. You can find it in our GitHub repository. And as Yonatan already said, the slides will be on our website, which will be also linked in the YouTube video. So you can find the link to the query there as well. But if you want to see it now, you can just access the Axon Git repo and see the queries. So let's move on to our second scenario where all objects are deleted from a bucket. Such data corruption allows threat actors to save time and effort, and we will soon see how easy it is to execute. And it also may have major impact on business operations, and this improves the chances of the victim to pay. In this scenario, the attacker iterates all the bucket objects and uses the delete operation to delete each of them from the bucket. He may also leak the objects prior to deleting them, demanding ransom for not making them public. And once the bucket is empty, the attacker may also delete it using the delete bucket operation. So as we can see, this does not require any special knowledge for the attacker, only the use of a really easy to use AWS API. The permissions you need in order to successfully execute this attack is the list bucket and delete object permissions. List bucket is used to iterate the objects, and delete object, as its name suggests, to delete the bucket object. So we can delete all objects using the delete object API. We can use the recursive flag to recursively delete all the objects in one command. And in this case, AWS runs the S3 list objects operation in the background, and this is why we need this permission. We can also batch delete all objects of a bucket using the delete objects. Notice the S that was added to the API name, and provide again the bucket. But this time we provide a local file with JSON that includes the files to be deleted. So this requires a prior knowledge of object names. For example, if you run AWS S3 LS, if we have this permission, we can get all the objects, or we can brute force object names. We can also batch delete all buckets and their objects, which is very destructive. And let's go over this quick one-liner. We can find all the buckets with the Axon delete prefix, for example. Then we can remove each bucket using the RB command. And using the force parameter, we can delete it even if it's not empty. So we remove all the objects and remove all the buckets.
Shelly, I'm pretty curious about this one, about this deletion ransomware in general. Like from what we got used to in the ransomware world, at least in the enterprise ransomware world, it is mostly about encryption, right? Sometimes exfiltration, but what is the advantages in AWS of doing deletion rather than encryption from the attacker perspective, obviously?
So again, a really good question. And as we already mentioned, the deletion operation is a very, very simple API. You really don't need to have any understanding of AWS and any mechanism like KMS. You simply delete an object. And also it requires a simple delete permission. And that permission is also contained in the famous S3 star permission, which is commonly used. Also, the threat actor may also steal the files prior to deleting them and demand ransom for getting them back or not getting them public. And when critical files are deleted, it really harms business operations, and it's way more likely that the ransom would be paid. So this really achieves the goal of harming the business operations as much as encryption does. So now that we've successfully simulated the activity, let's analyze the CloudTrail logs again and see how we can detect this activity. We can see a list object operation followed by sequential delete object operations in a short time frame, or one single delete objects operation. And I'm reminding you that we mentioned you don't have to perform the list objects, and AWS also does not perform it in the background since you provide the local file with the object names in a JSON. And these objects will be deleted without listing all the bucket objects. And in the resources of the CloudTrail event, you can see the ARN prefix. So we know that the deleted objects are in the Axon bucket 1, but we don't have visibility into the specific objects that were deleted using this API. So yeah, we already mentioned list object is not called by AWS because of the local file specifying the specific names. Also, I wanted to note that in my experience, there was no difference between successful and unsuccessful attempts. So in many AWS and CloudTrail events, I would expect to have an error code if something does not work. But here, when I tried to delete files and it didn't work because I had a bad parameter or I didn't have access to the delete object operation, there was no difference between my failed attempt and my successful attempt. So to sum up, our thesis is sequential delete object operations in a short time frame, or a single delete objects operation originating from a suspicious source. It may be an IAM user or an IP that you don't trust or don't recognize, and a user agent that is anomalous for your bucket or your users. And it is potentially following the list object operation and maybe also followed by the delete bucket operation. But do remember that this requires additional permissions. Also, you want to be filtering out activities that are originating from AWS services. So this is our query for this scenario. You can also find it in our GitHub repo. But make sure to really tune it according to your environment. As we all know, deletions happen all the time, and you really don't want to create an alert fatigue for your analysts. So make sure to tune it according to your environment. And to our last scenario, which is object deletion using lifecycle rules. As we've seen in the previous scenario, object deletion is a very effective way to achieve destructive impact and higher chances of ransom being paid. So let's look at another way to delete files, which is less straightforward to detect and more silent in CloudTrail. First, I want to discuss lifecycle policy for a minute. To those of you who are not familiar with it, it lets you transfer object to another storage class, which is less of what we're looking for. But the interesting use for our scenario is that you can also use it to expire objects, meaning delete them a certain period of time after you create them. So in this scenario, the attacker uses the put bucket lifecycle operation to make the S3 service delete all objects found in a bucket after a certain period of time. The attacker may also leak the object, as we already talked about, and once the bucket is empty, he may also delete the whole bucket if he has permission to do so. The required permission for this scenario is only the put bucket lifecycle permission, and put lifecycle configuration. And S3 list bucket is not needed here because you really don't need any knowledge of the bucket structure. S3 is expiring the objects for you in the background after the amount of time that you specified. And this is the only permission that you need. So for example, if you set the S3 put star permission for your bucket, know that it doesn't only allow the put object or put bucket policy, it also allowed the put lifecycle configuration. So to expire all objects of a bucket, we can use, again, the AWS CLI using the put bucket lifecycle configuration command, and we specify the actual policy using a local JSON file with our lifecycle rule. In this case, it has an expiration of 1 day. This has to be a positive integer, so 1 day is the minimal amount of time that you can set for your lifecycle policy. So our thesis, we're looking for a put bucket lifecycle operation with a short expiration time, which we can see in the request parameters. And the days field indicate the number of days until objects are expired. So it's likely that threat actors would choose a relatively short amount of time so that a bucket owner won't try to revert it.
Shelly, when do you say revert it? I think this one is very important. It means that the user can revert, like update or delete their lifecycle policy up to 1 day.
Yes, exactly. So you can use the delete bucket lifecycle API to cancel the deletion. And this really emphasizes the importance of real-time detection, right? So in such scenario, if you detect it in real time, you still have 1 full day to revert this harmful operation. And you really wouldn't have this capability if you wouldn't have a detection for this. So you likely won't notice that the lifecycle policy has been set for your bucket. So yeah, it's optional to revert it, but you really need to take a close look at your buckets to notice that. So our detection logic, we're looking again for a suspicious source, maybe a long-term credentials access key and a suspicious IP that we don't trust. And one quick insight is that if server access logging have been enabled, if you can recall from the beginning of the talk, we said that it's another option for auditing your S3 buckets. You can see the S3 expire object event. So it will generate once the object is expired. In contrast, in CloudTrail data events, you can only see the put bucket lifecycle event. And when the objects are expired by S3 automatically in the background, you won't have visibility into this. And again, this is our detection query. So really feel free to use it, tune it according to your environment. You can tweak the expiration days, for example, if you want. And yeah. So now that we've finished breaking down all the attack scenarios, let's talk about some effective ways we can reduce our attack surface and protect our S3 buckets effectively from these attacks. So let's start with our effective measures against S3 ransomware attacks. First, you want to use IAM roles for short-term credentials. You really want to avoid static IAM access keys, and it's especially important to not use an access key for your root user that has access to all your resources. And if you do use IAM users, please set up MFA for them. You should follow the principle of least privilege. According to the shared responsibility model, you're responsible for managing the security of your deployed resources, and you want to grant users and roles only the permissions they need for their specific tasks. And also, you should use bucket policies to allow only the required access to your buckets. So moving on to some S3 specific protections, you should enable S3 versioning. It can prevent accidental or unauthorized overwrites and deletions by creating copies of modified objects and using delete markers. So let's say we upload an object and then we modify it. Instead of overriding the same file, AWS saves a copy of the object with the new modification. And that way we have the previous version we can recover. So this is a very effective method in case of an unauthorized override. And if the attacker wants to override previous versions as well, it requires some additional permissions. S3 object lock enables you to store objects using a write once, read many model, and it prevents modifications to objects for a predefined period or indefinitely. Note that it can only be applied to version buckets, and it can only be set up during bucket creation. So this needs to be taken into consideration when you create your buckets. And you can also migrate your data, for example, from existing buckets into object lock enabled buckets to start applying this protection to them. Also, you should use AWS backup or bucket replication or any kind of backup that is separated from your actual bucket. AWS backup allows you to centralize and automate your backups across different AWS services. You can store them in different regions, establish lifecycle policies for managing the retention of the backups. And S3 replication is more specifically to S3 buckets, and it also allows you to copy objects between buckets, AWS accounts, and regions. And the bucket region should never have the same access control as the actual bucket you're backing up. So the last thing you want is that an attacker that gets access to your bucket would also get access to your backup bucket and override it as well. So please make sure to separate your access control. You should also implement server-side encryption with AWS KMS and use the customer-managed KMS key. So like we already mentioned, this allows you a granular control over key permissions to decide who can encrypt and who can decrypt objects using this key. And this actually provides another layer of access control on top of your bucket policy, because anyone that doesn't have the option to decrypt or the permission to decrypt using the KMS key can't really access object contents, even if he has the get object permission. So you really want to use this powerful mechanism, and make sure to also enforce the KMS encryption in your bucket policy. So if you set up the default encryption of the bucket as KMS, but someone uploads an object and specifies another encryption type in his request, his specified type will take precedence. So because of that, you need to deny object uploads that use other encryption mechanisms. So let's wrap it up. We've touched the ransomware landscape in the cloud, what S3 has to do with ransomware, and why we chose to focus on it in our research. We've discussed the anatomy of S3 ransomware attacks, how they're conducted, what is recommended for proper visibility, and delved into 3 attack scenarios of object encryption and deletion, touched the required permissions, and then follow up with the detection techniques in CloudTrail and how to identify and investigate suspicious activity. And finally, we learned how we can protect our resources from ransomware attacks in S3 effectively. So to wrap up, there are so many cloud services, and I really know the struggle of keeping up and prioritizing what to protect from, what to detect, and how to do so. So I hope you gain some insights and tools that will help you stay on top of threats in AWS, create better detections, and protect your resources effectively. So thank you again so much for being here, and feel free to reach out to me on Twitter or LinkedIn. I would really love to hear your thoughts and insights and have a chat about it. And I'd be happy to answer questions if you have any.
Shelly, thank you so much for this amazing presentation, like lots of practical insights and, things that security team can take right away from this talk. So thank you so much. We have some questions here. So someone asked, we are using GuardDuty for AWS detection. Does it detect the attack methods described in the webinar?
Yeah, good one. So actually, GuardDuty uses heavily machine learning-based detections based on the call volume and the source location. So realistic simulations, or maybe true positives with high volume buckets, or maybe VPN activated attacks where the attacker is actually in another location, they may be effective to test their detections, but in my experiments, they did not catch my simulations.
Yeah, and we shouldn't rely only on machine learning, right? We should have multiply products that can detect it. Okay, we have another one. S3 bucket is by default encrypted at rest. Then how ransomware threat exists? Can you elaborate it on this more?
Yeah, sure. So the server-side encryption is only applied, as I said, when the object is written to the AWS data centers, but it doesn't like have a granular access control like the KMS key, and it doesn't prevent anyone from accessing the actual contents. Once you try to get the object, AWS decrypts the objects in the background dynamically. So the default encryption does not prevent anyone with access to objects to read their plaintext content.
Amazing. We have another one. Does the suggested prevention practices give us a good coverage against ransomware attacks? The ransomware attack that described in the webinar, obviously. Amazon.
Yes, so definitely this really give a good cover. Both for recovering from such an attack and to prevent it. For example, if you use object lock, it's a really powerful mechanism, and the server-side encryption with KMS to prevent such access to your objects. So yeah, definitely it gives a really good coverage. And I would also really recommend you check out the S3 ransom response from the AWS CERT if you want to have another resource to check out.
Amazing. Yeah, we also always speak about, we should have a good detection engineering, but we also should have a good visibility for investigation after the incident. I hope it never occurs, but when, I guess it will at some point. So yeah, that makes sense. Thank you so much, Shelly. If you guys have more questions to Shelly, feel free to reach out to her at LinkedIn and Twitter. All the links will be in the slides that will be available. I know that I say it like tons of time, but it will be available at Hunter's YouTube channel after the talk. So thank you guys so much.
Another quick note is that we're also planning to publish a blog about it soon. So also you can wait for this one. It will be more comprehensive and also cover all the things we talked about.
Yeah, stay tuned for that. Thank you guys, and see you in the next Axon webinar. Thank you. Bye-bye.
Thank you.
Thank you, Shelly.